Hey guys, this is for a couple people that were asking questions about this particular section of homework and problem numbers. So wanted to just quickly make a video to go through them rather than just writing it out and hoping that you can follow along. All right, so I'm just going to go through these real quick. Feel free to follow along. If not, best of luck on the final tomorrow. All right, so this first one here is 13.1 homework, question number 9. Again, yours may look a little bit different on every single one of these. This is the problem that popped up when I pulled it up. So I've written them all down for the ones that were requested for the person that couldn't make it to the meeting today. But this one, you're basically trying to find the equation that we write as this a sub n, which stands for the nth term for every single one of these in this pattern, this sequence it's called. So each one of these represents a term of our sequence. We'll write this as A1, 2, 3, 4, 5, 6, and so on. And you can obviously see the pattern. Two things that are happening here. One is that the signs are alternating from negative, positive, here, there, and so on. And then also in the denominator, the numerator is not changing. In the denominator, it's all increasing by a factor of 1. And so with each of these two parts, we need to figure out a formula, an equation that will allow us to find the 26th term rather than just the next. Okay? So with this, we're going to take and try to rewrite this in a form that we can then find any term we want, hence the name, a sub n. So first thing I know that is going to happen is that there's going to be a -1 multiple to every single one of these, okay? And I'm going to put it to the power of n because how we're trying to rewrite this entire formula is solely dependent on the n in the term. And so when I put a 1 in there, I'd have -1 to the first power. And since it's a negative to an odd, I know it's going to stay negative. Now, if I put in the 2 here for the n, then I know it'd be -1 to an even power, which would make it a positive, which is exactly what we have there. 3 would be odd, so negative, even, positive, odd, negative, and so on. So I've got the negative alternating part taken care of. Next, I want to figure out if I can find how to get the 1/5, 1/6, 1/7, and so on. And in this case, we can see very easily that the numerator is not going to change, but the denominator, starting at 5, is going to increase by 1 each time. So since we're going to increase by 1 each time, we know that the number is going to be in for every single one of these because how many times I add something is exactly what I'm going to be putting there. So if it was adding 4 each time, it would be 4 for every n because I'd add 4, and then a second time would be 4 times 2, a third time would be 4 times 3, and so on. But I got to make sure that I am starting at what they asked me to start at, and that's the 5. So in order to get there, when I put in n is 1, like we said, that's what this represents. I need it to give me an output of a 5 in the denominator. And in order to do that, all I would have to do is add 4 to that. And so this is what I think, based on all of the differences from one to the next, is going to give me the nth term, any term that I asked to find. So just to kind of make sure that it works, a lot of times I'll plug in the 2, the 3, the 4, the 5, or the 6, just to try to make sure that I do get one of those other types. So let's just go over here and see about maybe this one here, the 5th term. And so if I was to find A5, then I know I'd be plugging in everywhere there was an N, that 5. And so I'm going to change colors here just so that you can see I'm replacing all of the N's with a 5. And I want to make sure that it gives me out that -1/9. And so my A5 would be Well, negative 2 in odd is going to stay negative. And then this is going to give me 1 over 5 plus 4, which is 9, for my negative 1/9 that I knew I had to get. Okay. So that one's pretty straightforward. I know it looks a little different, and there's not always a formula for every single type of scenario that we can come up with. So just be careful when trying to find these and just start with looking for the patterns. Okay. So this next one here, number 14 on 13.2, is going to have a similar look where they're going to ask us to find the first term, which that's pretty easy. It's 17. But they're going to ask us to not only find the nth term, that formula, that equation, but they want it in what is called a recursive form. How these things keep reoccurring or repeating. And if you can find a pattern, then you're off to the right start. And so this first one here, I'm looking, how do I get from there to there to there to there, and so on. And hopefully you can see pretty easily that we'd be adding 9 each time. So I've found how this is going to work out is going to be by adding 9 each time. And so if I wanted to write this as 9 in, that's fine. That would only give me 1 though, right? I'd have to make sure that when I plug in 1 for in, I would get more than 9. I need to get actually 17. So what we're going to do, since it's asked us to find it recursively, we don't even have to go this route. Recursive meaning that if I want to find the nth term, well, then I'm going to have to use the term before it and tell you how I take that and do what to it to get the next term. And we basically already found that pattern. We said it would be adding 9 each time. So if I know the first term, then all I got to do is add 9 to it to get to the next term. So again, just to kind of show you the pattern of this and what it looks like, if I wanted to find a of n, it says it's equal to a sub n minus 1 plus 9, according to me. And if I wanted to plug in what I am trying to find, which I said let's find a2, then if I plug that in there and there, it says to find a2, I'd have to use a2 minus 1, which is a1, and add 9 to it. Now, if I wanted to change that to A3, then the only thing that would change is I would take A2 and add 9 to it, and so on and so forth. So that's what they mean by recursive, is what process is reoccurring in order for you to get from one to the next. And there's a famous one that uses this called the Fibonacci sequence. So you can check that out. That is one of the most famous recursive formulas that we use and come across. All right. So the next one on 3.2 gets a little bit abstract for us. They want you to take this term, that term, that term, and any of the next, and see how you get from one to the next so that we can then use that formula to find the 16th term. So in reality, what we're trying to find first is a sub n. Even though they didn't ask for it, it'd be nice to know. And I need to find, first of all, the pattern to get from my first term to my second to my third. And as you can see, there are two different things going on in each of these. The A is changing as well as the B. And how is the A changing from the first term to the second? Well, hopefully you can say that it was adding 3A each time, as well as what is changing in the B's from each. Well, in this case, it looks like we're subtracting 4 B's. Now, as long as that works for the next one, if I add 3A to the 4A, I get my 7A. And if I subtract 4B from the 3B, I would get negative B. So this does appear to be what is called my common ratio, or how it's changing. And the formula that we use for any time it is using arithmetic, we call it arithmetic, then this is the formula that we can use. Now, again, this is not a recursive formula, so a sub n equals a1 plus n minus 1 times d, the common difference. And the only two things you need to know are what a1 and that common difference d are. We know a1, they gave us that. That was the a plus 7b. And then we need to know d, the common difference, which is what we had to come up with on our own, 3a minus 4b. And now that we know a1 and d, then we can find any term we wanted. So rather than me actually multiplying this out and trying to simplify it, don't stress. They didn't ask us to do that. All they asked us to find was a of 16. And we know the one and only unknown, even though I know a's and b's are typically variables, not in this case, we can plug in that one and only variable that is n of 16. So in order to find that 16th term, I now have everything I need. My first term, that now becomes 15 times the 3a minus 4b, my common difference. And after multiplying 15 to those to get 45a minus 60b, I can now add that to the a plus 7b to get my 16th term, which would be all my like terms, 46a, 7b's minus 60 of them would be negative 53b. And that would be what is called my 16th term. Okay, pretty straightforward. Just make sure that when you guys are dealing with all these, you not only have all of the formulas written down on your note sheet, you also know how to use them, more importantly. Okay, so the last couple here that I wanted to go over, very similar, but now we're into 13.3, which if you're looking at that section, which it's not going to have those all labeled on the final, you know that these are geometric in nature. So not arithmetic, not adding and subtracting anymore, but multiplying by some common ratio rather than adding or subtracting some common difference. So in this case, you've got to be able to find, just like before, the pattern. And these you can see grow very quickly, very fast, because they're now multiplying. So in this case, hopefully you can see, we're going to be multiplying by 4. And using a calculator, you can check that very quickly. Now, remember, they did want us to find A1 just to make sure that you know what you're doing. And then they wanted us to find, again, what is called a recursive. So what is reoccurring to get from one to the next to the next? Guys, we just found it. We're just multiplying by that 4 each time. So I'm going to take any term, a sub n, that I want to find, and I'm going to use the one before it, a sub n minus 1, and all I got to do to that is multiply it by 4, which a lot of times, instead of putting it at the end, they will put it in front. And that's how I'd get from one to the next, just like we did in one of those previous examples. But those were arithmetic because we used arithmetic, adding or subtracting to get from one to the next. This is what is called geometric because we're multiplying. Okay, pretty straightforward there. Last one I wanted to talk to you about, again, more of a little bit more difficult because it has the variables involved, okay, and more variables than normal. So they are now giving us our first term, it's 4. But then they're telling us how to find the k plus 1 term. Now, whether they write a sub n or a sub k, don't let that throw you. But instead of writing a sub n and using a sub n minus 1, the term before it, they're saying use a sub k plus 1, and it's equal to 1/2 a sub k. So again, you can see, hopefully, that this is just the term before this. So rather than writing the minus 1 for n, they're saying k plus 1, and the term before it is k. All right? So they wanted to find several different things in this one. And the first was, give me the first 5 terms. Now, they already told us the first term. So our first 5 terms, which I'll label, in the homework, they actually had them labeled each individually. A1 is equal to blank, A2 is equal to blank. I'm just writing the blanks horizontally instead of vertically. And I know the first one is 4. They gave us that. But then they told me how to find every term thereafter by just taking the one before it and multiplying it by half. So that would be what is called my R, common ratio. So all I got to do is start with that first term and multiply it by half. And if I multiplied each one of those things by half, I'd get 2. Half of that is 1, half of that, and half of that. There's my first 5 terms. The R, we just said, to get from one to the next was 1/2 by them telling us that. And then lastly, they wanted us to find A sub n, but this time in terms of n and not recursively, because they already gave it to us recursively. And that's why they used k rather than this, because they knew at the end they were going to ask this. So our last thing to fill in over here for parts A, B, and C, so to speak, was find the generic term for this. All right, so we know that, because we have it written down and we've studied this, for any geometric, it's equal to A1 times R to the n minus 1. Where when we did arithmetic, remember it was A1 plus n minus 1 times D. Okay, so again, have these written down. How can you differentiate between them? D is the common difference. That's arithmetic. R is our geometric common ratio. All right, so all you need to do in order to find this is know the first term and the common ratio, and that is the formula. And since they gave us both the first term and in a roundabout way the common ratio R, then we know the answer to this is A1 times R to the n minus 1. And be very, very careful, because this has an exponent. You will never be able to take this and multiply it with that unless these two are the exact same. And that rarely happens, so you are done. All right, so that's it. If you guys have anything else, try to hit up the discussion boards. I'll try to take a look at it today and tomorrow morning. Otherwise, best of luck. Have a clear mind, get some good rest, and be focused tomorrow. Wish you guys all the best. Take care.